To make box and whisker plots, they're actually kind of fun. I only need a couple sets of data. I've given you here a couple instances. There's the median of 5 of this data set. The minimum is going to be 0. The maximum of this data set is going to be 10. The first quartile is 3. The third quartile is 8. That's probably some weird numbers. I'm actually going to explain on the back what those mean. To find quartiles from a set of data, here I have 91, 91, 91, 97, 65, 37, 41, 76, 87. Not that bad. I can find a bunch of measures. I'm going to find the median first. To do the median, I put them in order. I got 37, then 41, then I've got 65, then I've got 76, then I've got 87, then I've got 91, 91 again, 91 again, then 97. Now that we're in order, I can find the median. Check it off. 1, 2, 1, 2, 1, 2, 1, 1. My true median is 87. It's actually going to be my second quartile. To find my first quartile, I have to find the median of these. To find what's halfway between 41 and 65, I take 41. Okay, 41, add 65. Then divide by 2. I'll get 53. So my first quartile is 53. My second quartile is, what's the median of here? I don't think between 91 and 91 is, of course, 91. That's how I find a quartile. Now, to make a box and whisker plot, I'm just going to go ahead and use those measures. On the other side, I said that my median was 87. My first quartile was 53, and my third quartile was 91. My minimum, my lowest number, was 37, and my maximum was 97. From this, I can make what's called a box and whisker plot. That's what they're called. They're called box and whisker plots because they look like there's a box and some whiskers. If I do that, I set 2 lines like this and draw a line in between them. This is going to be my minimum. That's going to be my maximum. Write that in. Min, max. My minimum was 37. My maximum was 97. It's a big spread. My median was 87. So between these, 87 is going to be in the middle, of course, but it's going to be actually closer to 97 in the grand scheme of things. It's going to be about over here. I'm estimating here. I'm not being exact by any measure. Now, 53 is going to be about halfway between 37 and 87. About there. My third quartile, 91, is going to be about halfway between 87 and 97. Now, what I'm going to do, actually, is connect my first to my third by using a box, like so. Now, we have this thing called the box and whisker. There's a box and some whiskers. What the box says is that half of our data, half of our information, is going to be within this box. That's a pretty good estimate about where most of the scores lie. If I'm looking at these are like test scores, it means most of my kids, half my kids, exist between the 53 and 91 range. They're somewhere in here. In addition, my median, which is my middle number, is actually pretty high. It's closer to the end. It's closer to my 91 and my 97, which means that, as a general rule, my scores were pretty high. They were higher than I would normally expect. In addition, I have these weird things. This far one is definitely called an outlier. This means it's lying outside what is considered normal, what's expected. It's way out there. There's a huge gap right here. One student did not do particularly well. He's probably alone. There's probably not many kids that did that well, otherwise they would be in here if they did any better. So that's how we do a box and whisker plot. Set your min, set your max, find your quartiles, first and third, find your median, mark it, make a box to connect your first to your third. I'm going to mark those down. And that's a box and whisker plot. We'll be able to read them, make them, talk about them. That's how we talk about data in the data world. Thank you. Have a good one.